We'll proceed in the innovative approach in calculus, and we will see what extra we can do in the product rule. Product rule, you are amazing, you are mind blowing. Means product rule is something that was invented on moon. Means it is kind of a, a cornerstone in the arena of calculus. So if we see the calculus, okay, so if we see, okay, so if we see the calculus, then the calculus is nothing different from the simple addition multiplication. It is only thing is that we calculate the addition based upon the area of a shape. How we how we calculate addition is nothing but area of a shape. This is called integral calculus. From there, we proceed in the calculus and we start finding the kind of formula, something that someone tries to formulate the procedure of calculating addition, calculation of addition through calculation of area. If I know area, then I get the addition. That is integral calculus. Like I say that every day I collect, or every hour I am working. First hour, first hour, in a sense that first hour I work kind of, first hour I, okay, I'm sorry. Let's consider that we are saying that, okay, consider that first hour a person is walking 3 kilometers. Next hour he is walking 5 kilometers. Next hour next hour he is walking 2 kilometers. How many kilometers he has walked? So first hour he walks 5 kilometers, 2 kilometers and 3 kilometers. Okay. One way is to add it, other way is to get the multiplication. But multiplication is not possible. Okay, I would rephrase it and let's try multiplication is possible or not. First hour, a person is walking 3 kilometers. Next hour, for 1 hour duration, that person is walking again 3 kilometers. Next hour, person is again walking 3 kilometers. How many kilometers he has walked? Then 3 into 3. Or next hour, again person is walking 3 kilometers. So 4 hour continuous, every hour he is walking 3 kilometers. How many kilometers he has walked? So this is pretty much addition. 3 plus 3 plus 3 plus 3, 12 kilometers. Or 3 into 4, 12 kilometers. Or, or now let's draw a graph. Let's draw a graph, and horizontal is a width, horizontal is width, and the horizontal is width and vertical is height. Okay, now the width is 4, the width is 4 and height is 3. I'm talking about rectangle which has a width of 4 and height of 3. Okay, now if that is the case, then what is the area of rectangle? Width is 4 and height is 3. Then there is one way called multiplication, that is 4 into 3. The other way is that, as I say, take a square, small square, take a square piece. Consider this is a square. If this is a square, it has width of 1 and height of 1. Now, place like this: 1, 2, 3, 4. Now, 4 in number, I keep in a one row. Then again on top row, again 4. On top row, again 4. This is what the rectangle is, right? Width is 4, means 4 squares are there. And height is 3, then since this 4, I am repeating 3 times. Now count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's simple, right? It is 12. So net addition is 12. If I take a square whose width is 1 and height is 1 and keep the square as per the hour, first hour, second hour, third hour, fourth hour. Then next row, first hour, second hour, third hour, fourth hour. Next row, first hour, second hour, third hour, fourth hour. So in 1 hour, first hour it is 3, next hour it is 3, third hour it is 3, fourth hour it is 2, it is 3. What is the area of this rectangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. So area of rectangle is 12. This means that net addition is 12. Now we will go back to our question again. Now first our person is walking 3 kilometers. Next hour he is walking 2 kilometers. Next hour he is walking 4 kilometers. Next hour he is walking only 1 kilometer. How many hours he walked? Then 3 plus 2 plus 4 plus 1. This much he walked. Okay, this is the pure addition. What about multiplication? Multiplication will not work here. Multiplication only works when there is a repeated addition. What about calculating the addition through area? Let's try. Okay, first hour I have to put 3 square. So this width belongs to hour and height belongs to kilometer. 1, 2, 3. Next hour 4 kilometer. Next hour 2 kilometer. 1, 2. Next hour 1, 2, 3, 4. Next hour 1. Now this is not an rectangle, but this is an area, haphazard, some area. Okay, if this is the area, what is the net area? Then let's count the number of square I have put. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I believe this is what it is. 10. Okay, so this is calculation of the area also gives the net addition. This is the thread that continued till it brought integral calculus. Okay, this from here we can calculate addition based upon just the calculating the area. There integral calculus began, and then people started talking about the if you see the top, the first top is 3, next top is 2, next top is 4, next top is 1. That every hour we are saying. Now number of hour is 50 lakhs. Number of hour here is 4. Number of hour is 50 lakhs. Or the granularity, granularity is second. Granularity is second rather than hour. In 4 hour, in 1 hour, 3,600 seconds happen. This is what I think so. So 60 into 60. So 36, 3,600 hours. So granularity is 6 second. Then 4 into 3,600. That many ticks will be there on x-axis. And we are calculating number of kilometers he is walking per second. Now it will be a smooth curve. Now someone has to find the equation of the curve. What is the curve? Curve is nothing that at any point what is the height? What is y? That is the height. What is function over x? Y is height, that is function over x. What is x? X is x-axis. At any moment on the x-axis, what is y? So whatever the graph I am drawing, can I get an equation of the graph? Is it possible? With dependent upon independent component x-axis like sin x, tan x, x square, exponential, logarithmic, full mixture of all these, can I draw whatever we are getting every second? If I able to get fx function over x in algebraic equation, then just integrate it and get the net addition. Okay, from the area we started calculating the integration formula, and slowly we say that just integrate it, get the area. Okay, from the area we got the integration formula, and after that we reverse it. Like if I am building a house, consider I am building a house, and when I am building a house, it is a pillar house. Now I am preparing one kind of, if it is a pillar house, then I am preparing to make the roof, the ceiling of the house. Now there will be concrete at the ceiling of the house. Then I have put many wooden kind of uh, wooden pillar, small wooden pillar, which would support to get the ceiling. Okay, because without wooden support, ceiling cannot stand. Now, lot of wooden pillars I have put on the ground, and they are supporting the ceiling. And now I am doing the concrete of the ceiling. After some day, ceiling is completely concreted. I take away all the support that I had provided. Now ceiling will give support to the wooden pillars. Now I can keep wooden pillar on top of ceiling. So first wooden pillar is giving support to the ceiling, and then ceiling is giving support to the wooden. Or I can keep inside it, and it will save it from rain. So that is concerned here. If I calculate the area, if I calculate the area, then from area I get the integral equation. Later, integral calculation stand on its own. Then through integral calculus, I get the area back. So that is at the beginning. Like if it is x-axis is x and y-axis is x to the power 0, then the net area computation is x to the power 1 by 1. If this is x-axis independent component and y-axis is x to the power 1, that is a triangle, then net area is x square by 2, that is half of the rectangle. I have demonstrated it many times. If it is x-axis and the curve is x square, then area underneath is x to the power 3 by 3. So it starts from rectangle and triangle, and later we believe that x to the power n integration is x to the power n plus 1 by n plus 1. What is the integration? If I draw a graph, then what is the area underneath? Indirectly, we are calculating the net addition. But someone will take, no. What is net area? It is very smooth. The curve is very smooth. It is smooth because our granularity is very fine. That's why it is smooth. There is nothing smooth in the world. Everything is digital only. This was proved by Mr. Einstein, Miss the greatest scientist of the modern era, Albert Einstein also. The energy that comes from the sun is not continuous. It comes in set of photons, and each photon, I believe, h nu or something is the formula that he gave. That much energy it is carrying. So there is nothing continuous. Everything is discrete only. But if this number of discrete items from one interval to other interval is so many, we consider it is continuous. So everything is discrete only at the end. Anyway, now why I brought this point is, as I talked in the previous video also, there are two things in calculus. One thing is integral calculus, and reverse of it is differential calculus. Like reverse of multiplication is division, reverse of addition is subtraction. Like that, fx into dx equal to hx, then dhx by dx equal to fx, getting fx back. Okay, so many people they proceed through differential calculus rather than integral calculus. Integral calculus is completely sitting upon algebra. If I say dx, it is not delta x when delta x tends to 0. It is not like that. If I say integration is fx into dx, then where dx is delta x, where delta x tends to 0. That is not true. Fx dx means actually it is fx into x, that is width into height, but height is dependent upon x. That is not a rectangle. In that sense, fx into x will not give the actual area. It will give something like area of a rectangle. To find the actual area, we just put a notation called d there. Dx is not delta x tends to 0. 0. That is primitive calculus. Dx is not delta x tends to 0. Dx is d is just given there so that it will not be read as fx into x. It will be read as fx into dx. Actually, it is fx into x if it is area. Otherwise, it is rectangular area. Otherwise, it is virtual rectangular area. In virtual rectangular area, it is put as fx into dx. D is inserted, claiming this is not rectangle. Through integration, we are calculating the area. One side is fx, function over x or y. Another side is x. But fx is not constant. If it is constant, then f constant into x will give the area. But if it is not constant, then fx into x will not give the area. Then we have to go by where from we had started x to the power n integration. In that sense, to differentiate from the rectangular area, we put d there. Dx is not delta x tends to 0. Okay, and limit is from what interval to what interval in between we want the area. If I have a graph that is drawn from origin to something, but we want the area from x1 to x2, that is the limit sign, that is snake sign x1 to x2. Otherwise, that is also not required. So that is integral calculus. But differential calculus, when we talk, I have x-axis and there is a curve like this. At any point x1, I have a height in the curve, that is fx. At any point x2, there is a height in the curve, that is fx2. Function over x is x2. Now, if I move x1 to x2, that is x2 minus x1 unit, x2 minus x1 unit, if I move in x direction, then how much fx climb? Fx is climbing, right? Fx1 is different, fx2 is different. If I move x1 to x2 in x-axis, how much fx1 climb to fx2? dfx by dx at x equal to 1. That is nothing but fx2 minus fx by x2 minus x1. If this x2 minus x1 difference is very small, delta x tends to 0. This is the new way of calculus. Delta x we take very small and tends to 0. Then it is fx plus delta x minus fx divided by delta x. Delta x fundamental is new concept, whereas the original calculus is integral calculus, where we get the net addition purely through calculation of the area. Width into height or height into width. Height is fx, width is x. Fx into x is the net area if it is rectangle. If it is not rectangular area, then fx into dx, then we have to go by some polynomial formula. Anyway, so we have seen the product rule. If I talk about product rule in differential calculus, product rule in integral calculus, that we will see. But we are going through differential calculus, product rule. That is, if I have a function over x, that is fx, and function over x is gx, then what is derivative of fx into gx, or dfx gx by dx? If I have x-axis and there is a graph called fx, there is another graph called gx, fx, gx. If I have any point x1, then fx is fx1 and gx is gx1. If I have another point x2, then it is fx2 and gx2. If I multiply fx1 and gx1, and then again I multiply fx2 and gx2, then what is fx2 into gx2 minus fx1 gx1 divided by x2 minus x1, dfx dx by dx, where x2 minus x1 is very, very small. I can say it is delta x, where delta x tends to 0. In that sense, we are trying to find fx plus delta x into gx plus delta x minus fx gx by delta x, where delta x tends to 0. This is new way to find the product rule. What is old way to find the product rule? That we discussed. The old way to find the product rule is, what is y? What is fx? At any point, consider that I have x-axis. Consider I have x-axis. I have x-axis, and this is the curve. This is the curve. Now, if this is the curve, this is x-axis, and this is the curve, then okay, it is not touching the x-axis. It is little bit up. In that sense, if little bit up, in that sense, if I have any point x1 here, then corresponding height is fx1. At that point, what is dy by dx? At that point, what is dfx1 by dx? dfx by dx at x equal to x1. What is that? If I say my y, if I say I have a line, I have any line, y equal to dfxy by dx at x equal to x1 into x. What line you are talking about? Y equal to dfxy by dx at x equal to x1 into x. I'm talking about a line at, at point x1. This is point x1. At that point, there is a graph called fx. And at point x1, this is fx1. At that point, if I say y equal to dfx by dx at x equal to x1, then I'm talking about a tangent line, that is y equal to dfx by dx at x equal to x1 into x. That is the equation of the line. If this line is passing through point x1, y1, then actual equation of the line is y minus y1 equal to dfx by dx at x equal to x1 into x minus x1. This is the full form of the line. Now, this is not we are talking about through the primitive calculus. Okay, what is what is y? At any moment, what is y? Primitive calculus is calculus that sits upon algebra. So what is y at any moment? Y equal to dfx by dx, dy by dx into x. What are you talking about? Y equal to dy by dx into x. At what point? General. Algebra means general. Generally, I am saying y equal to dy by dx into x. Where this comes into the picture? Where this comes into the picture? What is y? What is the height at any point? That is dy by dx into x. Where it is important, if I say at any point height, that is fx, height at any point is the derivative dy by dx into x. Where this comes into the picture? Now, if I have a x-axis, if I have x-axis and there is a point here x, and x any generic point, then this is fx. Y equal to dfx by dx into x. Now, at that moment, what is the dy? What is the change in the y I see when there is a change in x? What is dy? The dy equal to dy by dx into dx. Obviously, right? dy equal to dy by dx into dx. If I bring it back, dy by dx equal to dy by dx. Okay, okay, please be clear. Consider I have a function over x is sine x. Function over x is sine x. dy equal to sine x, dy by dx into x. Sine x differentiation is cos x. Y equal to dy equal to cos x into dx. True, right? dy by dx equal to cos x. Y equal to dy by dx into x if I say, then dy, if I differentiate y, dy equal to dy by dx into dx. If y equal to sin x, then dy equal to sin x, cos x into dx. Same as if dx, if I bring this side, dy by dx equal to cos x. Primitive calculus is very, very minute calculus. So I can politely say dy by dx equal to cos x, or dy equal to cos x into dx, or dy by dx equal to dy by dx into dx. If that is the case, then what about three dimensions? We are talking about two dimensions. Then z equal to dy by dx into x plus z equal to dz by dx into x plus dz by dy into y. What about dz? Dz equal to dz by dx into dz plus dz by dy into dy. Okay, this is where we came to our formula of product rule. Now dz by d, what about dz? Z equal to dz by dx into x plus dz by dy into y. What about dz? If there is a small change in x and y, then it is dz by dx into dx plus dz by dy into dy, where dz by dx is algebra. We are not talking about any point x1 and x2. That is the difference between the modern approach and the very generic primitive approach. Modern approach talk about delta x, delta y, where it tends to 0 at any point x1, x2. Forget it. Algebra means generic. This is algebra. So dz equal to dz by dx into dx plus dz by dy into dy. Now if I consider z equal to u into v, where u is function over x and v is function over x. Okay, u is an entity that is any function over x. It can be x square, it can be sine x, whatever. U equal to any function over x. V equal to any function over x. Then what is dz? dz, z equal to, consider z equal to u into v. Then du into v equal to du into v by du into v. dz, dz, okay, dz equal to dz by dx into dz by dx into dx plus dz by dy into dy. The first term derivative and second term derivative. If that is the case, and I consider that z is in variation of u and v, z is in variation of v, u and v, then du into v, du into v will be dz by du into du plus dz by dv into dv. I believe it is confusing. Let's forget everything and let's consider that instead of x and y, I have two coordinates, one is u and one is v. There is u and v. These two are independent to each other the way x and y are. If that is the case, then dz equal to dz by dx into dx plus dz by dy into dy, where x and y are two different orthogonal coordinate systems. Consider the orthogonal coordinate system are u and v. Then z equal to u into v. This is the function over u and v. Then du into v equal to dz by du into du plus dz by dv into dv. It is clear. Consider z is a function over u and v, not on x and y. U and v are two entities. They are orthogonal to each other, independent of each other. Then dz equal to dz by du into du plus dz by dv into dv. Consider z is a function over u and v, and that is u into v. I can take any function over u and v. U square plus v square. U sine u plus log u, whatever I can take in u and v. Consider it is u into v. Then du into v equal to du into v by du plus du into v by dv plus dv. Now du into v by du, when they are independent to each other, I can silently take out v, du by du gone. V du plus u dv. So the product rule du into v is equal to du is equal to v du plus u dv. Now consider u is function over x and v is function over y over x again. U equal to fx and v equal to gx. Then difference d of differentiation d of ux into v, difference d of fx into gx is fx into gx is gx d of fx plus fx d of gx. This is how yz equal to dx dy by dx into dx plus z equal to dz by dx into dx plus dz by dy into d, z equal to dx by dz by dx into x plus dz by dy into y. Please watch, I believe, last 2 or 3 videos. There we have very nicely demonstrated that how z equal to dz by dx change in xz plane, change in z with respect to x into x plus change in yz plane, change in z with respect to y, dz by dy into y. Now someone will say, your fundamental looks very nice. What about 3 dimensions? You talked about 2 dimensions, right? I mean 3 dimensions, right? What about 4 dimensions? 4 dimension in the sense, I want to calculate the differentiation of product rule. You are right. What about fx, gx, hx? D of fx into gx into hx by dx. This is what I want. Fx into gx into hx divided by dx, 3 multiplication. Okay, if that is the case, then if I consider the third component, now I consider uv alpha. It is a 3 dimension coordinate system, uv and alpha. That's it. Now z equal to, if three dimension is there, z equal to, that is also called density function, then z equal to dz by du into du, I'm sorry, dz, or z equal to dz by du into u plus dz by dv into v plus dz by d alpha into alpha, or dz equal to dz by dz by du into du plus dz by dv into dv plus dz by d alpha into d alpha. If that is the case, I replace z with u into v into alpha. That is the case, d of u into v into alpha equal to d of u into v into alpha by du, where u, v, alpha are independent to each other. It is a cubical shape. In that sense, then v and alpha would come out, du by du gone. So v into alpha dv plus u into alpha d, I'm sorry, v into alpha du plus u into alpha dv plus u into v d alpha. This is the multiplication for the all three. Now u I can replace with the gx, fx, v with the gx, and alpha with hx. Now it will be something like gx into hx dfx plus fx into hx dgx plus dfx into g plus gx into fx into gx dhx. Okay, someone can try. This is our way to calculate the This is our way to calculate the product rule. But someone can try it. Okay? A product rule of fx, gx, hx. Let's consider fx into gx is one term and hx. Then as per product rule, it will be fx into gx dhx plus hx dfx into gx. Now dfx into gx, if someone breaks, then it becomes fx dhx, fx dgx plus gx dfx, and hx is outside. If you combine, it becomes same thing. So primitive way of calculus, there is no concept of delta. It begins from the algebra, it ends in algebra. Once the result is in front of someone, then he is ready to place the numeric value whatever he wants. Now if d of fx gx hx equal to hx into gx into hx dfx plus fx into hx dgx plus fx into gx dhx, then now if result has come, then any can place the numeric value. But anyway, people are free to go by the delta approximation also. We have seen tons of things in delta approximation, where first product rule we try to find out through first principle, and that was fx plus delta x into h into gx plus delta x minus fx gx by delta x. Someone will introduce their gx plus delta x fx minus gx plus delta x fx. This, if I introduce in the numerator, then it becomes gx plus delta x into fx plus delta x minus fx by delta x plus fx, and then in bracket gx plus delta x minus gx divided by delta x, and altogether it becomes h plus gx plus delta x dfx plus fx dgx. Problem is gx plus delta x. There now, since delta x tends to 0, I can make it 0. The net differentiation of dfx into gx is net, it comes to first principle, is gx plus delta x into dfx plus fx dgx. dg this this gx plus delta x comes as unwanted. Now since delta x tends to 0, I now substitute it to 0. Same thing in linear approximation we saw. Let's consider fx equal to fx plus delta x equal to fx plus dfx into delta x plus error 1, gx equal to gx plus dgx into delta x, and then plus error 2. Or if I see the Taylor polynomial series, then I can go beyond that. Then fx plus delta x equal to fx plus dfx into delta x plus 1 by factorial of 2 d2fx by delta x whole square plus 1 by factorial of 3 d3fx by delta x to the power 3. Keep going. Like for gx, keep going. Now substitute there. dfx into gx is fx plus delta x, gx plus delta x minus fx gx by delta x. Now fx plus delta x full Taylor polynomial, gx plus delta x full Taylor's polynomial minus fx gx. Now keep setting error d error by error by delta x tends to 0. What is value or delta x? So this is the new way. Old way, that is our invention, that is not available anywhere. Old way, that is z equal to dz by dx plus dz by dy plus dz by d alpha plus dz by whatever comes. How it is proved, or how z equal to dz by dx plus dz by dy into y, this we have proved in the past video, that you have to watch. Okay, so we will proceed more on it and see how to calculate sinusoidal, how to calculate derivative of sinusoidal without first principle. First principle is sin x plus delta x minus sin x by delta x, where delta x tends to 0. Okay, that we will see. Please do support us. +91 is the India country code, 9483160610. 9483160610 is the telephone number, and +91 is the India country code.